two extra examples. We have three identical metallic objects. They carry the following charges: 3 microcoulombs, 8, and -5. So here's one object, let's say, they're identical. So it doesn't matter what they are, just think of them as spheres. There's 3 microcoulombs here. Remember that the micro is 10 to the -6, 1 millionth. Here we have another one, 8 microcoulombs and -5. This is number 1, number 2, number 3. Now, the first object is brought into contact with the third object and then separated. So we get the 3 microcoulombs and the -5. They're brought into contact and then separated. Then the first object is brought into contact with the second object and then separated. So now, before we go to this statement, let's figure out what happened here. If they're in contact, then there will be transfer of charge. Charge will move from one. Remember that it's a metal, and in metallic objects, charge moves freely. So here there's positive charge, here there's a negative charge. So charge will move between them. It will keep moving until, and since they are identical objects, until in the end the charges become equal. When the charges become equal, then there's no transfer, no further transfer of charge. So this means that since this has 3 microcoulombs, this has -5, the total charge on both of them is -2 microcoulombs. So this means that when I bring them in contact and keep them for a while in contact until equilibrium is attained, I'll end up with -1 microcoulomb on this and -1 microcoulomb on that. Because the total charge on them is -2, and that -2 will be spread equally, or it will be divided equally between the two objects. So now, at the end of this step, I had number 1 is -1, and number 3 is -1 microcoulombs. Now I bring, so this is number 3, this is number 1. Now I take the first object and put it in contact with the second object. So now I have the -1. I put it in contact with the second, which is 8. They're identical, so they have the same size. -1 and 8 microcoulombs. Again, they are identical objects, they are metals, so charges will move. You know, it's like the charging by contact. So charge will move from one metal to the other until finally the charges become equal, equally divided. So the total charge here is -1 plus 8, that's 7. That's the net charge. So this 7 will end up being divided equally between the two. So we'll end up with 3.5 on one, and on the third 3.5. On the second one 3.5. So finally, this is number 1, this is number 2, this is number 3. So number 1 will have 3.5 microcoulombs, number 2 will have 3.5 microcoulombs, and number 3 will have minus 1 microcoulombs. So that's final charges on each object. Now what's the number of excess electrons or protons on each sphere? If the charge is negative, it means we have excess electrons. If the charge is positive, like here, it means we have excess protons. So on object number 1, I have 3.5 microcoulombs, positive. So I have excess protons. How many excess protons? It's a charge, 3.5 microcoulombs times 10 to the minus 6 coulombs, divided by the charge of the proton. What is the charge of the proton? 1.6 times 10 to the minus 19 coulombs. So that's the excess number of protons. So we get around here 2.3 or so, 2.2 times 10 to the 13 protons. On number 2, same thing, 2.2 times 10 to the 13 protons. On number 3, I have excess negative charge, so I have excess electrons. How many? It's a total charge, which is minus 1 times 10 to the minus 6 coulombs, divided by the charge of the electron, because I have excess electrons. What is the charge of the electron? Minus 1.6 times 10 to the minus 19 coulombs. So I end up with about 6.25 times 10 to the 12 electrons. So that's the way it goes.